So we have now these two forms of the fundamental theorem of calculus, right? The second form we talked about is arguably the most important version in terms of any computations you could want to do. So before we look at an example of that, let's go ahead and look at an example of the first version, right? We just want to do something simple here. So here we want to do something like, let's compute the example, compute the derivative of, let's pick a good one here. Oops. So I want to compute the derivative of this function, f of x from pi over 2 to x. Let me change this actually. Let's start with this one, of sine of t dt. Right? So fundamental theorem of calculus says, well, if I want to differentiate this, since I have a constant down here and an x up here, all I have to do is take that x and plug it in for t. So sine of x. And that's it. One more example here to make this interesting is, let's say I have f of x equals the integral from 0 to sine of x of square root of t dt. All right. When I integrate this, it's a little more complicated because this isn't just an x here. But if you think about this carefully enough, this is really a composition of two functions. Maybe h of g of x, where we think of h of x as the outside function, which is this. Now this one we can exactly apply the fundamental theorem of calculus to, and then the inside function is just going to be that sine of x. Right? So we plug this into here. Right? It's a bit weird to think of at first maybe, but it's not that bad. So it's just a chain rule problem. So if I take the derivative of this, right, I should do the derivative of the outside, which means take the sine of x and plug it in here. Okay. Times the derivative of the inside, which is the bound itself. And there you go. Right, so fundamental theorem, pretty easy to apply. You might just have to think about it for a minute, but it's not that bad.